So we're going to consider sampling and sampling distributions. So you must understand that we've been dealing with populations and samples. A population is simply a set of all possible outcomes or measurements of interest. And the subset of a population is called a sample. So there are many populations that we can have under consideration, but particular interest is the term sampling. What is to sample? What is sampling? Anyone in your own definition? What is a sample?
I would say it's to get a smaller piece of the pie, smaller piece of the whole.
Okay. A sample is
A sample is just a small element of a population, a small element of a population that is picked for maybe for experimental purposes and whose results will be able to reflect that of the entire population.
Okay. So then why would we rather go for a sample than a whole population? What is the essence of sampling?
Because the population will be too large, so you deal with the small elements.
All right. A population may be too large, so we would rather deal with a small population. That's one of the reasons. What is the other reason why we would rather go for a sample and not the entire population? I'm loving your answers. Already what I can remember, you just told me that a population is a bigger sample space. Then a subset of this population is called a sample. So a sample can be a representation of this entire population. So the process of collecting sampling units in the entire population is called what? A census. So then the process of selecting smaller units of this population is called sampling. So sampling is important for many reasons. Number one, when we pick a sample, it may be a representative of the whole population. So sampling is what? May be sufficient to represent or may be representative. Examples, you're working for a brewery. We have testers who need to know whether the coke or the alcohol levels within range. There's an aspect of time. Again, we go for sampling because of time aspect. It will redeem us of time. Sampling is also important sometimes because of finance. You'll be doing your research and it may not be viable financially for you to do the whole population. Sometimes sampling is necessary because you may never be able to approximate the number of babies that are born in the whole universe. The universe size is simply too big, and sampling is the only option. You only approximate. All right. Why do we sample? Accuracy levels. Sometimes, which one is good? A higher accuracy level? A larger sample or a smaller sample?
Smaller sample.
Sometimes we have the destructive nature of sampling. Okay. Have a cure for HIV. and you'd rather work with a sample because you don't know your confidence levels. So we're going to look at what are called significance levels and confidence levels. All right. So under this topic, we're going to look at formulas in Wine. So we're going to look at sample formulas and proportion formulas. When I say sample, we're looking at what? Standard deviation. Proportions, we're looking at what? P and Q. So when you'll be doing your research, you'll be required to justify why you're using a particular sample size. So sample size is equal to Z squared, the variance over the error squared. That is if we're dealing with a sample. Or Z squared P times Q over the level of precision, error. The error comes in terms of within. If you're looking for confidence interval, we're looking for the mean interval, the range. Okay. Z standard deviation over square root of n. Or confidence interval, we are looking at it in terms of a proportion. Simply P plus minus Z PQ over capital N. Now, A stands for the error term. S stands for the standard deviation. We square it is a variance. So the Z score table, I have been teaching you how to read the Z score table. So we have what we call our confidence level. We have 99%, we have 98%, the common ones that I will give you, 95% and 90. The difference from 100 is called the level of significance. So here we have 1%, and here we have what? 2, and here 5%, then here we have what? 10%. So when you divide the level of significance by 100, it is now called alpha. I have 0.01. Here it will be 0.1? 0.02. Here it's 0.05. And here it's 0.10. So this is the song that I want you to learn. 99, 98, 95, 90. We have what? 2%, 1%, 5%, 10%. So far, are there any questions from what I've tabulated?
Mr. Collins, can you kindly go back to the previous page that you showed before this one?
Okay. I go to page that I've just showed. Any other questions before I go to the page?
Okay, my question is on this Z score. Is this given or you have to develop it?
You have to memorize these figures here. So on the Z score, we're going to look at a two-tailed test. For 99, it is 2.58. For 98, it is 2.33. For 95, it is 1.96. For 90, it is 1.645 or 1.65. So I want us to first learn this song before I go any further. So pretend to be like kids, all right? Let's go together. We have 4 confidence levels.
So disturbing you. I can see the screen.
Okay, can you see the screen? Now?
No, I'm seeing only Janik. I think his video is on.
Please switch off all your videos. Can you now see the video? Can you see my screen?
Yes, I can see it.
All right. Let's go to our song. We have 4 confidence levels. We have 99, followed by what?
98.
Then?
95.
95.
Then?
90.
90. These are called confidence levels. The difference from 100 is significance level. So we have what?
1%. 2%. 5%. And 10%.
And 10%. So we know that these two are adding up to 100. And when you divide this by 100, we call it alpha. So this is 0.01 then?
Yeah. 0.02. 0.05. And that's supposed to be 0.1.
All right. Then we have a corresponding Z values under two-tailed. For 99%, which is the same as 1% or 0.01, what is the Z?
Just come again?
2.5. The Z for 99%, 2.58. How about the Z for 98?
2.33.
1.33. For 95?
1.96.
1.96. And for 90?
1.65.
1.65 or 645. Either one is qualified. All right. Now, how did we get those figures at the far end? Is there a way in which we could calculate those figures from the table? Yes, there is a way. So what's the procedure? So I'll take you through the procedure of calculating that, but where possible, memorize them because the procedure is a little bit long. It is only important to know at least that this table will be given in case you're given a percentage outside those ones that I've mentioned. That's when I could recommend that you use the tables. All right, so let's go to the tables. So the table that we will use in particular will be the Z table, the standard normal Z table. Here is the standard normal Z table, the one you're given. So let me pick out 95. How did we get this 95? The rule is simply 1 minus alpha over 2. The answer you get, you read it from inside the table. So let's try at 95%. What is our alpha at 95%? 0.05. So 1 minus 0.05 divided by 2. How do we get? .975. So we're going to look for this one inside the table. You can get the exact figure or the closest possible. So when you go to 0.975, find it here. 0.975. What is the reading for this figure here? 1.96. So that is where the 1.96 is coming from. Let's try if we had 99%. What is our alpha at 99%?
0.01.
0.01. So what's the procedure for reading it in the table? 1 minus alpha over 2. All right. So what do we get? 1 minus 0.01 divided by 2. What do we get?
Zero 0.99.
995.
9950, is it? So let's look for 9950 in the table here. So the closest to 9950 is this one, right? 9951. What's the reading for 9951 here? Let's read it. 2 point what? 2.58.
2.58.
So this is where the 2.58 is coming from. 2.58, 1.96. And the song goes.
Are you able to repeat that for 99? Wasn't it supposed to, it was 1 minus 0.01 divided by 2, or no, didn't I?
1 minus 0.01 divided by 2.
Divided by 2. So the answer I was getting was this one.
Because you didn't use board mass, you first divide 0.01 divided by 2, then you subtract from 1.
So 0.01 divided by 2 will give you 0.009. And when you remove that from 1, it gives you 0.995.
Yes.
Thank you.
Okay, now let's sing our song again. Just tell me the Z value. This song, you appreciate it later because it keeps your mind what? Running. So 99%, 5%, 0.10, 0.01, 0.02, 98%, 2%, 10%, 95%. So just give me the Z values. I've given you significance levels, confidence levels, and alpha values. So let's start with this column here. What is our Z for 99%?
2.58.
2.58, correct. 2%?
2.33.
Good. 2% is the same as 98%, which is 2.33. I hope that's coming from your head. 95%?
1.96.
1.96.
1.96. 10%?
1.645.
1.645, correct. 5%?
1.96.
1.96, correct. 0.10?
1.645.
0.02?
2.33.
33. 0.01?
2.58.
58. Same as 99%. And 98%?
2.33.
2.33, correct. All right. So now let's find the missing figures here. So to find the missing figures, you should remember the formulas we had. Okay. So all these are looking for N. And N stands for what? N stands for what? Sample.
Sample size.
So now, part A is asking for sample size. Which formula do we use? So sample size only has two formulas. Either it's a sample, Z squared, S squared over E. Or it's a proportion, formula 2, and is Z squared PQ over E squared. E stands for the error. It comes in form of within. If P is 20%, Q is a remainder, 80%. All right, let's look at question 1, 2, and 3. So question 1, which formula do we use? Formula 1, right?
Yeah.
So N is what? Z squared, S squared over A squared. What is our Z? Question 1. $1.96 squared is coming from this, our sum. Our S, what is our S? Standard deviation is what? 2 squared over the error, 4 squared. So what do we get as the final answer?
Where are you calculating from? I can't see anything.
Are you calculating? Can you see?
Is it 15.37?
604.
Pardon?
0.9604.
The final answer is what?
So the answer that you got is
Okay, that's up to you and the calculator. So part 2, N is what? Formula 2, Z squared PQ over error. We're using formula 2 because we're using a proportion there. All right. So what is our Z? .58.
2.58.
And what is our P? 0.2.
2.
And what is our Q?
0.8.
8. Because if this is 20%, the remainder is 80%. Then our error is in percentage, 2%. So we're going to put 0.what? 0 squared. Don't forget to square it. All right. How about number 3? What formula do we use? N is equal to Z squared, S squared over E squared. What is our Z? 2.33. What is our S? 16. And what is our E? 5 squared. Why are we not squaring the 16?
Because it's a variance.
Because the variance, and variance is already a squared, right? Where's the 2.33 coming from?
From the Z.
The 2%, all right? From the Z value of 2%. All right. Sometimes you'll be asked to find the missing confidence interval. So A, if given N is 36, standard deviation, or the mean is 10, and the alpha is 0.05. Then B, told to find confidence interval, N is 50, right? And P is 10%, and significance level is 1%. And finally, C, given a capital N is 50, a small n is 30, and your alpha is 0.02. So how do we find the confidence interval? We only have two formulas for confidence interval. Like I said, it's either a proportion or a sample. For a sample, it's simply mean plus minus Z, standard deviation over square root of n. If you're dealing with a proportion, confidence interval is simply equal to the proportion plus minus Z and P over Q over capital N. Sometimes we're not given P, your P is simply what? A small n over big N. All right. So question number A, we're going to use formula 1. Confidence interval, what is our mean? Our mean is 10. Plus minus Z. Z is what? What is our Z here? Somebody help me.
1.96.
1.96. And the standard deviation is what? 12 over square root of what? N, which is 36. So 36, we only use Z when our sample size is more than 30. So here we have 10 plus or minus 1.96, and our sampling error there is 2. For square root of 36 is 6. 6 into 12 is 2. So here we're going to have what? 10 plus minus 3.92. So you first start with the lower bound by subtracting. 10 minus 3.92, we get what? 10 minus 3.92, we get 6.08. And when we add the upper bound, we're going to get 13.92. So we are 95% confident that the true mean will lie between 6.08 and 13.92. We are 95% confident that the true mean will lie between 6.08 and 13.92.
Sorry, Mr. Collins, how did you get the 2? That's 2 in the brackets.
12 over root 6. Root 16 is 6. So 6 into 12, that is a 2. So this is coming from this calculation.
Oh, okay. All right.
Then part B, we're going to use what? Formula number 2 for the proportions. So our P is 10%, so 0.10. Our Z at 1% is what? 2.58. Then we are going to have what? Square root of PQ. Our P, 10%, meaning what is our Q? 90%.
90.
And our N, which we have, is 50. All right. So when you multiply 90 times 10 over 50 and square root it, we're going to have 0.04. 0.04 or 0.05. 0.05, you multiply it by the Z figure here, 2.58. It's 0.129. So 0.10 plus minus 0.129. You want, you can put them in percentages since these are proportions. Plus minus what? 12.9%. So the lower bound will be 12.9 from 10, negative 2.9% to 22.9%. So here we are 99% confident that the true proportion will lie between negative 2.9% and 22.9%. But if you don't know how to comment, just leave it like that. You get the full marks for this confidence interval. Now, part C has given us an amazing arrangement. There's no proportion there. It's just N is equal to what? 50, N is equal to 30, and the significance level of 2%. So I said sometimes you're not given proportion directly. Proportion is simply what? Small n over capital N. So 30 over 50 will give us a what? A 60% or 0.6. So this means that our Q will be what? By default, 1 minus P. So the difference between P and Q gives us our Q. So our Q is 0.4. Are we together? So meaning, using formula 2, our proportion will be Z. Some formulas will put alpha over 2, but people end up dividing this. So I usually leave it out in my calculations, alpha over 2, because it's the same Z song that I've been teaching you. So on our proportion, we're going to put 0.6. On our Z, we're going to put 2.33. And our P is 0.6. And our Q is 0.4. Capital N of these two, you pick the bigger population, which is 50. So if you compute that, you're going to get 0.2. So when you subtract, this is 0.4, 0.8. So we are 98% confident that our true proportion will lie between 40% and 80%. All right. So that is how we finish sampling. Now, how do exam questions come? And how do I handle a question like that? Any questions before I go? I only have 2 minutes.
Are we by any means going to look at some of the examples for how the exam comes?
Yes, especially because he repeats the questions from the tutorial sheet. So we'll look at this again in the evening. I know some of you have Peter fiance have Peter Mabati. An African mind understands twice. So firstly, so at least at least the level of understanding I'll have when I'll be teaching this again will be different. All right.
Is it just me or the screen has gone blank?
It's gone blank.
Is it black?
Yeah, it's only black.
Even now?
Yes.
It's
You
black.
can only see the case. You can only see the case.
It seems my. How about now?
It had come on, but again, it's black. I think the connectivity is quite not good.
Okay, even now you can't see anything?
No.
I can see something.
It's on now.
Okay. So let's look at just one question before I go from our question bank, our Bible. Any questions asked? I'm looking for a question. I'll share the tutorial sheets that you could check on. So this is where school begins, because these are questions that will require you to now think and apply everything that we've been learning. So a question will come like this. A sample of 35 teenagers. So I wish you could do test 2s because test 1 is very limited. Refer to a random sample of 35 teenagers who average 33.7 hours of sleep. Assume the population a standard deviation of 1.8. Find a 95% confidence interval. So what have we been given? From the question, what do we have?
We have the n, the number, or is it the sample of 35?
N is 35.
We have the standard deviation of 1.8.
Standard deviation of 1.8.
And so 3.7 is what? The mean?
Meaning 7.3.
Mm-hmm.
What's Z?
The Z value?
And the Z of 95%.
So what's a Z from 95?
1.96.
So how do you find a 95% confidence interval? What format we use? Mean plus Z, standard deviation over square root of n. All right. So 7.3, 1.96, then 1.8 over square root of what? At 5. You get it, eh? Are we there?
Mean plus minus.
Yes.
Okay. Anyone lost on what has been done there? Okay. You don't need to calculate that. You just need to get the principle from there. Okay. Yeah. So let's also look at another question from the previous exam. Those of you who did the deferred test discovered all those questions came from, they already compounded my question bank. So perhaps let's look at the 2022 paper. November. Okay. Okay, so let me, it's a 2022 QM, 2021. Let's see on normal distribution. Let's see on confidence interval. Is there anything? Okay, here, part E, 4 marks. A sample of 500 Zambians contains 96 people who speak language other than English. Construct a 90% confidence interval to estimate the proportion of people who speak English, who speak the language other than English at home. So what have we been given here?
The sample size.
Big N, which is what?
500.
Small n.
Mm.
96, right?
96, and then the Z value, 1.64.
Small n over big N. All right, so Z value will be what?
1.645.
1.645 or 1.65, all right? So what formula are we going to use here? So N is what? 500. And small n is what? 96. So I mean they want us to calculate the proportion. Just small n over big N. So 96 over what? 500. Which is what? So we're going to use a formula for proportions, which is equal to P plus minus Z PQ over what? N. This is better than memorizing probabilities and conditional probabilities. It's very straightforward. So whenever you're given two populations, you're being asked to compute what? Our P. So 96 with 0.192. Then meaning our Q will be what? 0.808. And our Z at 90%, what is our Z? 1.65. So here we have what? 0.192 plus minus 1.65 over 0.808 times 0.192 over the capital N, which is 500. From there, you can take it up. Okay. Are we moving together?
Yes.
Anyone behind? Please ask.
I want a quick explanation on the P. So when you give us a scenario like this, P is what? P stands for what? Population or?
Proportion, the proportion.
Oh, okay, proportion. So the formula for proportion is n over small n over big N.
Yes, if you're not given a P. If you're given P directly, you go as it is.
Okay.
So tomorrow he will look at this. This is the sample, your thing that he is going to consider.
There's a black thing that has come on your screen.
All right. Able to see now?
Yes.
Okay, so I suppose let's look at question number 2. Okay, this will be your homework. So we've been given this question here. What can we get from there? Suppose the average annual consumption of milk in Zambia is 23.4 per person. Standard deviation is 7.1 per person. If 40 people are selected, what is the probability that the average milk consumption will be less than 25 annually? Okay. So we'll look at more of these questions in the evening, but I hope you get the concept of what I'm trying to bring across. So you need to understand the song and the formulas that are related to the song. Thank you so much.
This makes more sense.
Thanks.
This makes more sense. Thank you.
And here, have a good day.